Bright QT. Every student matters.
Hello children, welcome to the session. In this session children, we are going to discuss some of the question and answers from the topics that we have covered so far. So children, the first question is how we can tell the directions with the help of a magnet. So children, we know that whenever we suspend a bar magnet freely, it will always come to rest in the same direction, which is north-south direction. So children, how we can find the directions with the help of this magnet? Because we will let it suspend freely and it will show us the two directions, north and south. And if we know the two directions, we can easily find the other two directions, which are east and west. So with the help of magnet, we were able to find the directions. Okay. Next question, what is a magnetic compass? So children, magnetic compass is a device which helps us to find the direction. How? Because there is a magnetic needle pivoted at the center of the compass, and its north is the north tip. The tip of the needle, which always points in the north direction, is painted red in color. And children, it will always come to rest in the north-south direction. No matter where we take the compass, this needle will always come to rest in the direction of north-south. Okay, why? Because we know whenever we suspend a magnet freely, it shows the two directions, which are north and south. It will always come to rest in the direction of north south. So children, if we know the north direction and south direction, we can find the other directions easily. So this was all about magnetic compass, and it was mostly used by sailors, and it is still used by sailors to find the direction in the ocean also. Okay, because this compass will always point in the geographical north and south directions. Okay, these were the question and answers from the topic that we have covered so far. Children, we are going to discuss some of the question and answers from the topics that we have covered so far. So first question is, children, how we can convert a strip of iron into a magnet, and how? First question is, can we convert an iron strip into a magnet, and how? So children, suppose you have an iron strip and you have to convert it into a magnet. Can you do it? So first part of the question answer is yes, we can convert any magnetic material into the magnet. And how we can do it? What we can do, children, we can bring a bar magnet near this, and with one of the poles, say we start by rubbing the north pole, and we start rubbing it from this direction to this direction. Then again we will lift it and again bring it back to the first edge and start rubbing it in this direction from here to here. And children, when we keep doing it for around 40 to 50 times, we will observe that this strip of iron has been magnetized. And we can verify this by bringing any magnetic material near it, and you will observe the attraction, which will prove that we have converted successfully this piece of iron into a magnet. And children, one more thing, the edge from which we start rubbing it becomes the north pole, and from the edge where we are lifting it and taking it to the first edge, it will become the south pole of the magnet. Okay children, so it is clear to you how we can convert any magnetic material, say an iron strip, into a magnet just by rubbing any pole of the bar magnet to this. And we just have to make sure we are rubbing it only one direction. Okay, we will have to lift it from here and again we will start rubbing it in the same direction. Okay, and we have to repeat this process at least 40 to 50 times in order for the magnetic material to get converted into magnet. Okay, now let's move to the next question, which is how we can make our own magnet with the help of a needle, cork and water. So children, what we are going to do is we will take a cup of water, okay, and we will take a needle and we will start. The first step here is to magnetize this needle. How we can magnetize this needle? We have learned the process. We can magnetize it by rubbing it with a piece of bar magnet from one direction to the other, then lifting it and again bringing it back to the first edge and again rubbing it in the same direction. And we will have to repeat this process 40 to 50 times in order for this needle to get magnetized. And once it is magnetized, we have obtained our magnet. Okay, now we will take a cork or piece of foam which can easily float on water, and we are going to insert this in the center of this needle into it, and now we are going to put it in this cup of water so that it is free to rotate on the surface of water. It is floating on the surface of water, and it will be free to move. And children, whenever you move it, you will let it move it and let it rotate freely, and when it comes to rest, you will observe that in each case it is pointing in the same direction. And in order to verify this direction, you will bring a compass, and you will observe that it is always pointing in the north-south direction. And we are aware of the fact that whenever we suspend a magnet freely, it always points in the direction of north-south. So this also proves that we have magnetized our needle, and our compass is ready as it shows the north and south directions, right? We can find the other two directions easily. So this is how we can make our own compass using this property of magnetizing it. Okay, so let us now move to the next question, which is fill in the blank type question. First question is, artificial magnets are made in different shapes. What are the different shapes can be? We can make a bar magnet, we can make a horseshoe magnet, or we can create a needle magnet, which is used in compasses, right? Needle magnet. So we can make any shape, and these artificial magnets, children, these are much more powerful as compared to the natural magnets. Then the next point is, the materials which are attracted towards a magnet are called as magnetic materials, right? These are called as magnetic materials. So children, we have learnt about two types of material, which were magnetic and non-magnetic materials. What were magnetic materials? Magnetic materials are the materials which can be attracted by magnet, whereas the materials which cannot be attracted by the magnets are non-magnetic materials. So can you give me some example for magnetic material? Right, you can give me so many examples. Iron or nickel, these are the examples of magnetic materials. And what are the examples of non-magnetic materials? These can be wood, plastic, aluminium, etc. Okay, so let's move ahead to the next point, which is paper is not a. So you have to read each and every question very carefully, because children, most of the students don't read the question properly, and they will end up writing paper. They will read it as paper is a, and they will write non-magnetic materials, but it is saying paper is not a. Then you will have to write magnetic material. Paper is not a magnetic material, and why? Because it cannot be attracted towards a magnet, right? Okay, so next question is, in olden days, sailors used to find the direction by suspending a piece of magnet. How, children? Because they knew the property of magnet, that whenever we suspend a piece of magnet freely, it will always point in north-south direction, right? And last part is, a magnet always has two poles. Okay, so children, poles always occur in pair, so each and every magnet has two poles. Okay, then let's move to the next question, which is, it was observed that a pencil sharpener gets attracted by both the poles of the magnet, although its body is made up of plastic. Name a material that might have been used to make some part of it. So children, all of you have seen a sharpener, right? So it has a blade in it, which is usually made up of iron. Okay, so children, when we brought this sharpener near any of the pole of the magnet, either north or south, we observed that it was attracted to both the poles. So what could be the possible material over here? So children, the material could be iron or any other magnetic material. So and because of which it was attracted towards both of the poles of the magnet. It was a magnetic material, and it could be iron. Next question is, children, where are the poles of bar magnet located? So children, suppose we have this as a bar magnet. So where are the poles located? So children, at the edges of it are the poles. And how can we verify it? So children, what we will do, we will take a piece of paper. On this we will put some of the iron fillings, iron fillings, and then we will bring this bar magnet near this, and we will observe that these iron fillings will start clinging towards this magnet because they get attracted, and they will be attached, or they will be attracted towards the bar magnet in a particular pattern. You will observe that most of the iron fillings were clinging to the poles of the magnet. Okay, this indicated that poles are at the edges of this bar magnet. Okay, then next question is, how is a compass used to find direction? So children, how is a compass used to find direction? So children, compass is a structure like this, and it is enclosed in a glass structure, right? And it has a magnetic needle pivoted at the center of it, and one of its edge is marked with red color, and this will always point in north direction, and its opposite side will point in south direction, because it is a type of magnet, right? And this is free to rotate. And so children, this compass comes marked with all the directions, and when we know the north and south direction, we will automatically be aware about the other directions. Okay, and in this way we were able to find the directions using compass. Okay, so let's just read about it once. So children, a compass is a small case of glass. Okay, it is a case of glass, and a magnetized needle is pivoted inside the box. So inside the box there is a magnetized needle. So children, the needle can rotate freely. Compass also has a dial with the directions marked on it. So children, this has a dial, and it has all the directions marked in it, like northeast, southeast, southwest. All the directions are marked in it, along with the degrees which are also written there. Okay, and what are degrees? Degrees are there to measure, okay, to mark the exact location of any place. And children, the compass is kept if it is kept at a place where we want to know the directions. When the needle comes to rest, it always indicates the north-south direction. Why? Because we know that magnet, when suspended freely, will always point in north-south direction, right? Then children, the compass is then rotated until the north-south directions are marked on the dial are at the two ends of the needle. Usually different colors are used to point the different ends, and mostly the north direction is marked with red color. Okay, so let's move to the next question, which is, name the shepherd after which the magnet was named. So children, we have heard the story about the Greek shepherd, and his name was Shepherd, and his name was Magnus, and he was the one responsible who accidentally discovered magnet. How? Because on his shepherd stick, it was made up of iron. This edge was made up of iron. So when he was going on his route, he was walking, this got attracted to a piece of black stone, and he observed certain force with which the stick was attracted towards this black stone. And children, this was later identified as magnetite, which is a naturally occurring magnet, and this is how magnet was identified. Okay, so let's move to the next question, which is, how can you separate a mixture of magnetic substance from a mixture? So children, you have a mixture of different substances in which magnetic and non-magnetic materials are there. So how you can find out which are the magnetic particles? Very simple. You will bring a piece of magnet near this mixture. All the magnetic materials will get attracted towards this piece of magnet, and you can easily separate them. Okay, why? Because children, what are magnetic substances? Magnetic substances are the substances which gets attracted towards the magnet, right? And so children, this is how you are going to separate the magnetic substance from a mixture. Next question is, children, at which place on a magnet its magnetic force is maximum? So children, we have this magnet with the poles north and south. The place where this has maximum magnetic force is these poles, north and south. And how we can identify this? We can verify this with the help of an activity wherein we will take some iron fillings. Okay, these are the iron fillings. Just imagine them to be iron fillings. Okay, now what you're going to do is you will bring this bar magnet near these iron fillings, and you will observe that whenever we are bringing this bar magnet closer to these iron fillings start clinging towards this magnet, because they are attracted towards the magnet, and you will observe a certain pattern in which these are attracted towards the magnet. And what is the pattern, children? That most of the iron fillings were clinging at the edges, which are known as the poles of the magnet. And children, this proved that the place on the magnet which has the maximum magnetic force are its poles. Okay, these were the question and answers from the topics that we have covered so far. Thank you so much for your attention.